Hello, calculus friends. This is an interesting problem. We're asked to use the shell method to find the volume of the solid generated by revolving the region bounded by the curves and the lines about the x-axis. In this case, we have y equals the absolute value of x divided by 3 and y equals 2. So I'm going to show you a couple of things first. To visualize this, it's kind of a couple ways you can visualize it, but then getting that equation might be a little bit tricky because of, thinking about absolute value function may not be familiar. So instead of y, so we have y equals, and we can do the absolute value. Well, actually, no, you can just do your little lines on your keyboard, x. There also, you can get the functions down here too, I think, if you do more functions. I think you can get absolute value. They're also just on your keyboard. I may be making this up. I thought they were there. Oh, actually, it's right here. There's the absolute value right there, but that's kind of a cool place to do it. Okay, so the absolute value of x divided by 3. So that's that v you may remember from a previous class. And then we have y equals 2. And then clearly, if you want to get this pretty picture like I have, you can see that you need to restrict this in the x from -6 to 6. So you could do -6 is less than x, which is less than +6. Just to get that piece of the graph, and then the same thing here. And then, to get this, because you're going to revolve it around the y-axis, which you can just visualize. But if you want to be, I don't know, this is just kind of a fun thing to do in Desmos. You basically need the reflection across the y-axis of these two curves, which you could just, copy this and then do a negative. And then just put a negative right in front. And you'll get that one, and then you can copy this one and then put the negative there. So then you can see that, get that graph. So that's all pretty fun and nice to do. And so we're using the shell method and we're revolving around the y-axis. So you can see you have like this revolution. Let's see here. Okay. So you've got you revolve this around the y-axis. So you've kind of got a revolution here and here. So if you imagine a shell, in this case, our shell is going to be parallel with the x-axis, right? I'm sorry, because we're revolving around the x-axis, right? And so they're going to be expanding along the y. So we're going to have y limits, and we're going to integrate with respect to y. So our formula for the volume, we have the 2 pi, and our limits are depending on whether we revolve around a horizontal axis. If that's the case, then you're going to use y limits. Or if you're revolved around a vertical axis, you use x limits. So it just depends on what you're doing. So in this case, we're revolving around the x-axis. So we're going to integrate with respect to y. We're going to have y limits. So we're going to expand these shells. We're going to continue to expand them. They get bigger and bigger along the y, right? So those nesting dolls are bigger and bigger along the y. So they're going to start at 0, and they're going to go all the way up to 2. Our shell radius, when you just revolve around one of the axes, is just going to be whatever the other letter is. So in this case, it's going to be y, because that's just this distance. What is this distance right here? That distance is y. Okay, now the shell height, you have to put your thinking cap on a little bit. I'm going to erase some of this so I'm not confused. And that it's really this length that you have right here, right? You need that length. You can really think of it's because of the symmetry, it's twice the length from the y-axis out. So it's really twice this length. That's one way to think of it, right? So what is that length? Well, you're dealing with the curve y equals the absolute value of x over 3. You might remember another way to express absolute value of x. So if you wanted to think y equals the absolute value of x over 3, you can set that up as a piecewise function. That's just going to be x over 3 when your x is greater than or equal to 0. And it's going to be the opposite of x over 3 when your x is less than 0. And that's because you take the negative of it to make it positive. That's why I have that opposite there, that negative sign there. So if you need to express this in terms of y, especially this curve, this is y equals x over 3. So you can think of this as x equals 3y. And you have that, you double that. So because the whole distance, or you could say subtract, if you think of the x is equal to negative 3y, also you have the 3x minus the negative 3x, which makes positive 6x. Or you can just think doubling, you have 3y minus negative 3y, which means you can just double them. So that would be 6y. Okay, so this length is 6y. And then dy. And so that's your shell radius, that's your shell height, and we have the 2 pi. So this is 6y squared. So we are going to integrate. We'll have the 2 pi. We're going to integrate from 0 to 2. And then this is going to be 6y squared dy, which of course is just going to be 2 pi. And then that'll be 6y cubed over 3. So 2y cubed. And you'll evaluate that from 0 to 2. And then so you'll have the 2 pi. And then 2 onto 2 cubed minus 2 onto 0 cubed, which is, so this is 8 times 2 is 16. This, of course, is just 0. So we get 32 pi as our final answer. Okay? All right. I hope that helped.